So line Q is y equals mx plus b, which is the standard slope-intercept form, and where m is less than 0. So we know we have a negative slope. Does line Q pass through the point 5, 4? So negative slope means the line goes like that. So in order to know, really, we basically need another point on the line to figure out what's going on. Statement 1 tells us that when the line, whatever it is reflected around the x-axis, line Q passes through 3, negative 4. So when you reflect something around the x-axis, it's the y value that gets flipped. It gets flipped around this axis this way. So the real line passes through the point 3, 4. On the other hand, since we're being asked whether line Q passes through the line 5, 4, so if we were to draw this out, 3, 4 might be here, 5, 4 will be here. The only way it could pass through it is if it's a horizontal line, and we already know that the slope is negative, not 0. So basically this is sufficient to tell us no, it doesn't pass through point 5, 4 because it passes through 3, 4 and is not a horizontal line. So statement 1 is sufficient, and we can cross off B, C, and E. Statement 2 tells us when it's reflected around the y-axis, line Q passes through negative 5 and 3. When you're reflecting around the y-axis, you're reflecting this way, so it's the x value that you have to swap back. So the reflected version goes through negative 5, 3. The non-reflected version goes through 5, 3. Once again, so we can say 5, 3, and the question is asking, does it pass through 5, 4? Well, again, it would have to be a vertical line to pass through both 5, 3 and 5, 4, and we've established that the slope is less than 0 rather than being like undefined or something like that. So this one's also sufficient to tell us no, it doesn't pass through that point. Each statement on its own is sufficient. Answer choice D.